So we just created the class objects. That's we have it here, and then class objects, and we have the instance of the objects, and then we call our methods that we already added here, the add data types type in the add methods which define instance variables, and this is the method variables. This is the, you see that there is, I need to discuss a little bit later when why we need to create the instance object, and because there is no static methods. This is really very simple but standard public methods. That means if you have no static definition, static keyword here, that you cannot access these methods variable directly uh, directly to your other application or other class methods or in main class methods. That means if it's very simple methods, the standard methods, you need to be create the instance of the class, and then you have access these methods and call these methods and input the necessary input parameters. So we have create instance of the objects, and then we put our we called our objects, and then we fill it the add methods. So, and then let's see how can I run it here. So let's say I can debug it and stop it. Then the things to me clear. Waiting class, and then sorry, just for understanding how the static works. So we define the instance because instance of the objects, and then we call the instance object, call the add methods, and then and get the values for this value variable and print these values. How let's see, run it. So it says that's true. This is 1 plus 1. So you see the 1 plus 1, that means you have a local variable, and the local value is 70, 10, and then this is 10 value is fixed, and then you have input value 1 plus 1, that means it's total 12, the local variable. This is the effect that I said. So we pass that parameter. Let's see, you have a 2 plus 2, that means you have to be get it 40 or something like that. You get the 40 values for the instance. So you got the idea what means the local variables, and how can you define the local variables. Means you variables need to be defined inside the methods. You cannot put the local variable as a static variables, and then so on and so forth. And let's see how can you access your static variables. So you see the static variables, I didn't create any instance classes. We did simply class dot your variables names, and then every time you call the create the objects, it's automatically injected the same value, because you cannot change because this is called the statics. You cannot change the value of your instance variables. So how many times you call it, you got every time the same value of your variables. So if I call the 4 times, of course it's get the 4 times value of 10, 10, 10, 3 times 10, 10, 10, 10, because you cannot change the value of your static variables. That's the meaning of the static keyword. And then also the static variables, if you define it, and then static means it belongs to the class level, not the instance of a class level, and you can directly call the static variables into the without creating any instance class, and then just class name dot your static variable names, and so on and so forth. This one things. So okay, then it's the important part of what we already discussed. This is the one of the class, the methods we defined it here. So this is the static public static methods, and void methods. It's just simply printing how can voiding works. That I already discussed in the presentation. So if we have an integer value, like some reason in some methods or some classes or some interfaces or something like that, some implementations, you need some conversion, maybe maybe you have need the input value in the methods like a plot value, and sometimes you need to be plot value to the integer value. That's why the variable weighting play a really good role. So if an integer value a integer value 10, and then you need to be get this value as a plot value, and then you have it's like plot your primitive data types, and this is called the f, and then f value, and input it just simply varies. This is called the weighting of the two different data types, the integer to plot. And then this is here. If I run the class methods again, again we run it, so it doesn't change anything anymore. So it's see that the effect of this. So you have integer input value, and you try to weight it in the plot value, and then it's get the plotting value. So this one, even though you can you can do it like other data type, you can also convert it like what you like to do, integer to double or plot to doubles, and this is called the migration or plot weighting from between two variables, between two data types, between two data type variables. So variable narrowing or typecasting, you see the how the typecasting come to the play. You have a plot variables like plot variables 10.5, and f is flat the plot variables. If you do this one, this is the compilation error. That's true. Integer a and type plot, it is not possible because you have the upper versions, upper data type to the lower data type. Then you need to be somehow to typecasting or narrow down the your data types. So you see the plots and see the plot data types, and then you convert it like integer a, and then this is the calibrated, this is the called the typecasting. So you have a plot value and you flagged it like integer and put it the integer value and type it like this one. So let's have a run it. So see it, you put it like the integer value, the plot value with low typecasting, you get the integer value that you expected, that you want to see, that or that you want to convert it by the typecasting or narrow down your variable data type. And then this is the variable overflow. You have a integer value a 130, and you try to get it from as a byte value. You see the byte support the byte primitive data type v, and then byte and then you have a, and then you can print it with the byte type. This is called the overflow of your variables, two types of variables. So let's have a check it how it's look like. So you see the overflow, variable overflow. So you have a data type 130, and then you have the byte value is 130 converted to the minus 260, or maybe one check it like 100 the variable types, and then run it. And so it's 100 to 100, and then maybe 120. So what effect? So 20, 130, and see the overflow of your between data types of the values. And then you have the variable adding lower types. If you have two byte variables, the local variables byte value 12020, if you try to get it the byte lower data type, to add these two variables, the value 1 and value 2, the byte value, and you see the byte value c, and you need to byte and c, and then you have to be calibrated the first brackets, you need to be put in the byte value, the lower type of your data, to add the two variables. For integer other cases you don't need it, because the lower type of data you need to be flagged it byte value. So let's have it checked. So it works automatically. That's the compiler. If you go to this here, you see the compilation error. It doesn't work because of the lower type of data. You cannot add directly value 1.